Okay, so we just went through the first, what was this? 7 minutes, 4 minutes of the animato video, and we talked about how animation occurs. And we went over and we kind of learned that animation is just kind of an illusion of movement. We're going to put a bunch of pictures together, and we're going to show them in rapid succession, and each picture is slightly different than the last one. And then when we show them all together, it looks like it's moving. It looks like animation is happening. So that's really one of the key things that you need to understand in order to completely understand this lesson and what we're going to be going through today with what's called the draw loop. Okay, so on here in lesson 10, which is what we're doing today, code.org. Oh, look, we got more responses. Isn't that great? Okay, so here we go. We're going to, oh no, sorry, lesson 11, not lesson 10. Lesson 10 was last time. Here we go. We're gonna scroll on down here. Today's got a lot of videos. Okay, so well, no, we got one video, and looks like just some exploration and skill building and other stuff. So not probably a lot of coding, but very important concepts to be able to understand. So how can we animate our images in GameLab? This lesson introduces what's called the draw loop, one of the core programming paradigms in GameLab. Students learn how to combine the draw loop with random numbers to manipulate some simple animations, first with dots and then with sprites. So we've got function, that's the draw, and then we have world.framerate are two things of code that we're going to be looking at. And then we'll move on to the next one. So you just read that. So here is the another explanation of animation for that hopefully will help you to understand the concepts that we're talking about.
Movies create the impression that characters are moving slowly. But if you slow them down enough, you'll realize there are lots of individual images. Each image is just a little bit different from the one before. Speed them back up, and your eyes are tricked into thinking you're watching real life motion. A very simple example of this effect is a flipbook. The key to animation, whether on paper or a computer, is that part of the drawing is changing over time. An easy way to achieve a change is to use the random number command to generate a new random location, size, or color for the shape we're drawing. Here's a simple program that draws a single rectangle with a random X position and random Y position. If we run and reset this program over and over again, we can see that it draws the rectangle in a new position each time. But that's on Flipbook with only one page. To create real animations, we need to be able to string these pages of the flipbook together. In GameLab, we'll do this using the draw function. The draw function is special in GameLab. The commands inside of the draw function are run line by line from top to bottom. But once the computer reaches the end of the commands inside the draw function, it jumps back to the beginning and repeats the commands over and over again, as long as your program is running. Because the code in the draw function repeats in a loop, we'll just refer to this as the draw loop. Let's move our rectangle inside the draw loop and see what happens. Wow, so many rectangles. We can see that a rectangle isn't just being drawn once anymore. GameLab is automatically calling the commands inside of the draw loop many times a second. In this program, that means that a new random X and Y location is generated, and then a rectangle is drawn over and over and over. You can place as many commands as you like inside of the draw function. For example, let's choose a new fill color before drawing each rectangle by placing a fill command inside the draw loop. Instead of always choosing the same color, we'll randomize by replacing the red value with the random number command. So in every frame of the flipbook, the computer is picking a new shade of red and setting that as the fill color. Then it picks a new X and Y value and draws a rectangle with those values. In a typical animated movie or flipbook, you don't continue to see all of the drawings that came earlier in the animation. Instead, you have the illusion of a single shape or character moving over time. We'll discover how to make that happen with the draw loop soon.
Okay. So hopefully with the explanation of this video, you guys are understanding that what we're doing is we're running the same lines of command or same lines of code over and over and over again. Once you enter the draw loop, it's always going to stay inside the draw loop. So if I put a command after the draw loop, is it ever going to get executed? No. So keep that in mind as you're designing these programs. Yes, Kale. That's what I think they get into that next lesson, actually. So here's an example of the draw loop at work. Run the code and see how it works. Discuss with your partner whether this looks like the flip book you saw in the video. Why or why not? So this looks like it's going to be the same sort of thing that they had with the example. Okay? So we're just getting a bunch of dots that are appearing on the screen. So what do you guys think? Talk to your neighbor. Is this the same as the flip book or not? And why or why not? I'm going to pause the recording. We'll come back. Resume the recording. So as we saw here, this is not the same as a flip book because it's continually drawing a new shape. Each time, if we were in the flip book, it would have a new page that would be drawn. And this is what we're referring to as a smooth and fluid kind of animation. And as was requested, we will be learning about how to do this a little bit later, maybe in this one, maybe the next lesson. Okay, so now it's your turn to do some work with the draw loop. Remember that the code inside the draw loop is run by GameLab over and over again. Add code to the program so that your drawing has orange circles being drawn too. Move on when your program looks like the picture to the right. So currently, this is what we're seeing, just green. Okay, so how do I add orange? What do I do, AJ? Okay, I have to add into my draw function. What am I adding? I need to do a new fill, and instead of green, I want this to be orange. And then what else am I going to put in, Patton? Right, so I can just duplicate this code here, maybe. So I'm just gonna copy and paste here. So copy this and then paste it here. And then I got my thing. So I'll have a green and an orange each time it goes through the draw loop. So that's the effect I get. Exactly what I want. Okay, everybody got that? Yeah, well, it's random, so. Okay. Next, we're gonna go through till we get to the practice. Prediction. This program has one small difference that will make it run a little differently. Again, though, remember, all of your code outside the draw loop is run first one time. All of your code inside the draw loop is run over and over forever. What will this program do? Okay, so look at this. What is going to happen here? We have frame rate equals 5, no stroke, background blue, fill yellow, draw loop, background red, and then we have a random ellipse. So what's going to be drawn on here? Everybody turn to your neighbor, make a prediction, and see if you can figure out what's going to happen. Okay, we're making our official prediction now. So everyone, stay tuned. Here we go. We've got a blue background is going to be drawn. What then is going to happen? What's next? Karen. No, Michelle, sorry. Yellow circles. And where are they going to occur? AJ? All over the place. Like nobody's business. All right, hold on. And Aaliyah said something too. Oh, wrong thing. Wrong thing. Here we go. My chat. It's not going to show me my chat. Lame. Oh, there it is. All right, Aaliyah says blue background and the yellow filling will not appear because they are not in the draw loop. Okay, she thinks that it's not going to show the yellow filling because it's outside of the draw loop and it only executes once. Noah, what do you think? All right, so Noah actually is kind of on to what's going to happen here. Blue background is going to be drawn, but inside the draw loop, it's going to draw that red background over and over and over. And so we're just going to see a yellow ellipse that's going to appear in random locations all around the screen. So yellow is going to be over the red background. Okay, ready? So why do we not see the blue background, guys? Jackson. It's not necessarily ignoring, but it's just drawing on top of that blue background constantly. So the blue background's there, it's just all the way at the beginning. But every time it's going through the draw loop, it's drawing a new red background. So we never actually see the blue background. Okay? Right. So great question. If we were to go in to, and actually I can't change it, it's on view only. But if I were to comment out this red background, then we'd see a whole bunch of yellow dots everywhere, and they'd be on top of a blue background. Okay. So this is where we get our uniform and our fluid drawings. Each time we have to redraw the background, and then we can move this in a more uniform manner. Okay, so putting that into practice here, changing sprite properties, you can animate your characters. So we have this sprite that we set up as this green alien, and we're going to rotate him at a random number between -10 and 10. And we're going to draw the background each time. So what he's going to do is he's just going to look like he's dancing, right? So if I went in and undid this background, watch the difference that it makes. Okay, see how it gets like big like that? It's because it's just drawing the sprite. But when I draw the background each time, it looks like I only see a single alien instead of a whole bunch of them. You guys see the difference there? You want the fluid motion of your sprites, and you don't want what's called like an after image. You have to redraw the background each time. Oh, I'm supposed to run the code, discuss, try changing numbers. Oh, that's it. So I'm supposed to change these. So let's do like 50. 50 to 75. Watch how much difference he makes now. So what would happen if I, instead of having a orange, if I made a random, I need an RGB color. Here we go. Let's do random between 0 and 155. It's not what I wanted. Show text. Here we go. Random number, 0 to 55. Random number, 0 to 55. Random number, 0 to 55. All right, check this psychedelic out. Yeah. Let's move him back to, there we go. Okay. All right, so this is basically kind of the introduction. What they're gonna have you do now is practice, I think, so we'll do this last one, and then the next one's the practice. That's what you have to do on your own. So the animation is already updating one sprite's X property, make it look like it's shaking. You need to edit the code to make sure the second one shakes like the first. So you see this guy's moving back and forth, okay? You've got to edit this guy to move back and forth as well. So on here, all we're doing is we're creating the X to be a random number between 100 and 110. So the X of the brush also needs to be what? A random number. Should it be between 100 and 110? No. We want it to be on the other side. So what should it be between, Kyle? 300 and 310, okay? So we're just gonna take our random number, put it in here, and then instead of 1 and 10, we're gonna do 300 and 310, okay? And then our brush will vibrate just like the pencil. Okay, any questions what we've done up till this point? It's magic. It's actually called animation. Okay, so this then completes the introduction to lesson 11, the draw loop. Hope you were able to follow along. If you have any questions, please make sure to contact me via email, and good luck on the rest of your lesson.